In this example, we're going to calculate a limit by using the graph of the function. So use the graph of the function to find the following. If they exist, the limit as x goes to negative 3 from the left, the limit as x goes to negative 3 from the right, the two-sided limit as x goes to negative 3, and the function value at negative 3, so f of negative 3. So here's the graph of the function in this particular one. All right, so first off, we want the limit as x goes to negative 3 from the left. So we will be approaching from the left over here as x goes to negative 3. And for these x values here, as I get closer and closer to negative 3, the functions on the graph that correspond to those will be on this little piece right here. And if I keep following that, the closer and closer I get to negative 3 here, the closer and closer those points are going to get to this open dot right here. And that open dot has a y value of 3. And so therefore the limit as x goes to negative 3 from the left of this function was going to be positive 3. Next up, we want the limit as x goes to negative 3 from the right. So we'll be over here on the right-hand side of 3, and we will be getting closer and closer to negative 3 here. So for x values over here on the right side of negative 3, you can see where the graph is located right here. So if we follow the graph in here, getting closer and closer to negative 3 here, if we follow those points in, right, the y values on those points will be getting closer and closer to this open dot right here. And that open dot has a y value of negative 1. So as x gets closer and closer to 3, the y values are going to be getting closer and closer to negative 1. So the limit as x goes to negative 3 from the right of this function is going to be negative 1. So we know both of the one-sided limits as x goes to negative 3, the limit from the left and the limit from the right. So therefore we know what the two-sided limit is going to be. Here, both the one-sided limits exist, but the issue is that they are not equal to each other. One is 3, and the other is negative 1. So therefore, the two-sided limit is not going to exist. If the one-sided limits are not equal to each other, that automatically makes the two-sided limit not exist. We can't say that the function values are getting closer and closer to any specific value as the x values get closer and closer to negative 3. They're not getting closer to 3 because if I stick to the right, they're getting closer to negative 1. I can't say that the two-sided limit is negative 1 because on the right side it's doing something totally different. So the best that we can say is just that the limit as x goes to negative 3 of f of x does not exist. The function value at negative 3, what I would do is look at the graph here, since that's all the information I have, and I would find the filled dot corresponding to that, and here it is. And if I look over here, it has a y value of positive 2. So what that means is that f of negative 3 is equal to positive 2. So again, one more occasion to notice that the limits may not have anything to do whatsoever with this number, with the actual value of the function. And you can also see that if I move this point around, if I had it here, right, and I didn't change anything else of the function, it would not change the limit from the left, it wouldn't change the limit from the right, it wouldn't change the fact that the two-sided limit wouldn't exist. So really, the function value doesn't really have anything to do whatsoever with the limits. They are separate issues there. So once again, the limit from the left, positive 3, the limit from the right, negative 1. Since the one-sided limits are not equal, the two-sided limit doesn't exist. And f of minus 3, the actual function value at negative 3 is positive 2.